Hi all, my name is Divya and now I'm going to explain about anomaly detection. In this section, I'm going to cover what is anomaly and what is anomaly detection, types of anomalies and methods and types of anomaly detection, applications of the anomaly detection. Coming to what is anomaly. Anomaly are outliers or instances or collections of data that occur very rarely in the dataset and whose features differ significantly from most of the data. That is, if we have a dataset and there are some values that deviate significantly from majority of data that do not belong to the dataset. Those are called anomalies or outliers. And there are some types of anomalies like global outlier, contextual outlier, and collective outlier. Global outlier or the object significantly deviates from the rest of the data set. And contextual outlier, we say that object deviates significantly based on the selected context. For example, 28 degrees centigrade is an outlier for a Moscow winter, but not an outlier in the another context. Like 25 degrees centigrade is not an outlier for Moscow summer. And collective outlier. A subset of data objects collectively deviate significantly from the whole data set, even if the individual data objects may not be outliers. And coming to what is anomaly detection. Anomaly detection is a process of finding outliers in a given data set. Outliers are the data objects that stand out amongst other objects in the dataset and do not conform to the normal behavior in the dataset. Uh, in the anomaly detection, we found these outliers and removed from the dataset. And then next, these are types of anomaly detection. These are three types. There are three types of anomaly detection: unsupervised, semi-supervised, and supervised detection. Coming to unsupervised detection, for example, in some application scenarios, objects labeled as normal or abnormal or anomalies are not available. That means labeling of the dataset is not available. In that case, an unsupervised learning method has to be used. Unsupervised outlier detection methods make an implicit assumption, and there are some challenges in the unsupervised anomaly detection. Like normal objects may not share any strong patterns, but the collective outliers may share high similarity in the small area. And the largest unsupervised methods develop smart ideas to tackle outliers directly without explicitly detecting clusters. And coming to semi-supervised methods, in many applications, although obtaining some labeled examples is feasible, the number of such labeled examples is often small. That means we have a data set, some are labeled and some data is not labeled. We can say like that. In such cases, semi-supervised approach will be taken. And coming to supervised, we model an outlier detection as a classification problem. Like if we have a data set, we the data set will be completely labeled like normal and abnormal data values. And these are the methods of anomaly detection. Density-based techniques which include KNN, and cluster analysis-based techniques which include k-means clustering and Gaussian, and one-class support vector machine and Bayesian networks. Coming to density-based techniques. For suppose we have considering this first figure, we have many points in the figure, and we can see that at the C1 the density is more, and at the C2 the density is less, and O3 and O2 and O1 O3 is far from the other points, like the density among the O3 is very less and it doesn't belong to any other groups. So we can say that the O3 is an anomaly. Likewise, there are many real-world datasets demonstrate the more complex structure, where objects may be considered outliers with respect to their local neighborhoods rather than with respect to the global data distribution. And coming to the cluster analysis based techniques. The main idea behind using clustering for anomaly detection is to learn the normal modes in the data already available, and then using this information to point out if one point is anomalous or not when new data is provided. Here we follow general steps for the processing. First, we select the best model according to your data in the clustering analysis, and then fit the model to your training data. This may be a little complex depending on the chosen models. And the third step is once new data is received, compare it with the results of the model and determine if it's normal point or an anomaly. And the last point is if there is any kind of data evolution over time, the model should be retrained after a while in order to learn new behavior. Uh, the last model is the Bayesian. Coming to the Bayesian model of detecting outliers. Bayesian networks are well suited for anomaly detection because they can handle high dimensional data which humans find difficult to interpret. While some anomalies are clearly visible by plotting individual variables, often anomalies are far more subtle and are based on the interaction of many variables. These are the methods of anomaly detection. And coming to the applications of anomaly detection, there are many applications for the anomaly detection. For example, fraud detection. If the buyer behavior, the buying, for example, if we consider a credit card purchase, the buying behavior of someone who keep the credit card is different from that of the initial owner. Credit card companies try to identify theft by viewing for buying designs that characterize theft or by perceiving a change from general behavior. And for example, considering the intrusion detection, attacks on computer systems and computer networks are customary, while several attacks, including those designed to disable or overwhelm computers and networks, are obvious. Other attacks, including those designed to secretly gather data, are complex to identify. These are some of the applications where we have to do the anomaly detection. And for example, if we consider the mm, one more one more field, like one more application in the public health field. In some countries, hospitals and medical clinics report several statistics to national organizations for more analysis. For instance, if some children in a city are vaccinated for a specific disease, such as measles, then the appearance of a such cases scattered across several hospitals in the city is an anomalous event that can denote a problem with the vaccination programs in the city. And coming to the conclusion, the goal of anomaly detection is to find data points that are significantly different from the rest of the data. Although anomaly detection is based on probability theory and some statistics, those are very more number of techniques to implement it. Like previously discussed, clustering techniques and clustering techniques and support vector machine, Bayes networks, and there are many more techniques. Thank you.